Okie dokie. In this video, I'll be going over 2 more examples of this problem. If you need more breakdown or want to see kind of demonstrations of all the other rules, feel free to check out the first video for 612A I have done. I'm going to try to do these a little bit faster. Let's get started. So we're trying to find which of these expressions is equivalent to x to the 19 over 42. We can ignore this. All right, so now let's start with 8. This we can rewrite as x cubed, so all the inside stuff, and we know it's raised to the 6th, but then it's now going to be raised to the 6th over 7 on account of the 7th root. So then the 3 and the 6/7 are on the same level, and that means we're going to multiply them. So 3 times 6 is 18, and it just stays over 7. So this the 3 only gets multiplied to the 6 when you're multiplying 3 times a fraction like that, okay? So then we're left with this. This does not match this, so A is not our answer here, okay? B, let's simplify what we can do. So each of these we talked about before, how they can simplify like so. So whatever the root number is becomes your denominator in your exponent. So we're doing x to the 2/3, x to the 2/7, all over x to the 3/6. If we can simplify anything, go ahead and simplify it. 3/6 is equivalent to 1/2. If we have 2 x terms on top multiplied by one another with different exponents, we can combine them by adding their exponents. So 2/3 plus 2/7. So 2/3 plus 2/7. And that's all over x to the 1/2. Now let's go ahead and just keep simplifying this. When we have x terms divided by one another with different exponents, we subtract their exponents. So it'll be 2/3 plus 2/7 for the first exponent, and then we're subtracting the denominator's exponent of 1/2. Let's use a calculator for this. So 2/3 plus 2/7 minus 1/2. 2/3 plus 2/7, plus 2/7 minus 1/2. And we get this crazy decimal, 0.45238. X to the 0.45238. So again, that becomes the new exponent of our x value. So then the question is, could this decimal match this fraction, 19 over 42? So a quick way to check that would be 19 divided by 42, and it turns out that these two are equivalent. If you did have Desmos, then you would just hit, once you calculate this decimal, you could just hit this little fraction button right here in the top left to give you the 19 over 42. But if you didn't, this is how you would go about it. Just type in the fraction given in the answer to see if it matches the decimal you got. So anyway, B is our answer here because we found that this matched x to the 19 over 42. All right, let's do one more example. Let's see. Do I want to go through all of them? I think I can see where I've hidden the answer here. So I'm just going to try to work out, I'm just going to show what the answer is just for time's sake. I'm not going to work all these out. I apologize. If you have any questions on how to work out any of these, just let me know. But I'm just going to work out the correct answer to show why it equals the answer. All right. Or to show why it equals whatever they're asking for. So first step, let's distribute the 2 to each of these powers here. So we'll have x to the, so 1/7 times 2 would be 2/7. That's divided by x to the 4 times 2, so it'd be 8. And then on the bottom, we have x to the 8th, but it's underneath a cube root, so x to the 8/3. I would probably work out this top fraction first. So when you have x divided by x, 2 different exponents, we subtract their exponents. So that's our new numerator. And then we are still dividing by x to the 8/3. And then if we have 2 different x terms with 2 different exponents, we subtract their exponents. So I'm just going to do it all in one swoop again like I've been doing. 2/7 minus 8, that's the top one, minus the denominator's exponent of 8/3. So whatever this is will give us our final answer. All right, let's do 2/7 minus 8 minus 8/3. 2/7 minus 8 minus 8/3. Yep. So we get negative 10.38, x to the negative 10.38. So now, negative exponents. I addressed them in the last video, but I have not done so in this video. X to the negative value is equivalent to 1 over x to that same value, but now positive. So x to the, 1 over x to the 10.38 instead of x to the negative 10.38, okay? So then, we could do 218 divided by 21, and we show that that is also equivalent to 10.38, or you could just hit the fraction button on the last calculation there to show it gives you negative 218 over 21, which would have, translated to 1 over x to the, 218 over 21. 218 over 21. All right, anyway, there's two examples somewhat worked out. If you have any questions on the rules or any variations of this problem, please let me know. All right.